Hey guys, guess what? It's everybody's favorite thing, graphing, and also transformations. So we're at chapter 9.4, and the good thing about graphing sine and cosine and tangent, which is what we're going to be doing, is that we get to use this concept that we've really talked about a lot, and that is the concept of a parent function and a parent table as well as a parent graph. So if you guys remember the parent functions, we have parent functions for every type of function. In the case of sine, our parent function is just y equals sine theta, right? No frills, no numbers, just y equals sine theta. So I want you guys, rather than just give you the parent function, I want us to generate the parent function. And we're going to do that using our unit circle. So if I have an angle of 0 degrees, guys, I'm going to pull down the unit circle. Here's 0 degrees. What is the sine of 0 degrees? Well, if you remember, the sine is the y coordinate. So the sine of 0 degrees is 0 degrees. Oh, sorry, 0, not 0 degrees. Okay, now notice this is radians. They're keeping us in radians, so really 0 radians. So let's find pi over 2 on the unit circle. That's up here, pi over 2. What's the sine of pi over 2? Well, the sine is the y coordinate, so the sine of pi over 2 is 1. So I'm going to put a 1 right here. Sorry about all the moving up and down. Okay, let's go look at the sine of pi. Pull it down again. Let's find pi. Pi's over here, right? So what's the sine of pi? The sine of pi is 0. So I'm going to put that in here. Almost done. And then we get to sketch it. Okay, what about the sine of 3 pi over 2? Well, let's find 3 pi over 2 on the unit circle. And we can see right here the sine of 3 pi over 2 is the y coordinate, which is -1. And then 2 pi is the same as 0. So I'm back at 0 here. So let's see, what does this look like? Well, I'm going to graph. Notice my x-axis is no longer numbers. Now I've got angles, radians. So I'm going to graph 0, 0. I'm going to graph pi over 2, 1, pi, 0, 3 pi over 2, -1, and 2 pi. Okay, guys, this is called one period of the function. So one period of the function means I cycle through the table, right, from beginning to end. And now I don't have values 5 pi over 2 and 3 pi, but does everyone see how I could just continue the pattern, right? So if they ask me to graph more than one period, all I have to do is just continue the pattern. So that is the parent y equals sine of theta. Okay, guys, I'm going to scooch this up a little bit. If you guys remember, we've got A, B, H, and K, just like we did with all of the other super fun transformations we've done. So if you guys remember, anything on the outside, and this time it's not x, it's theta, but anything on the outside of the function affects the parent y values. So if you remember, the A is vertical stretch or compression. Right? So if I'm doing this, that means if I have an A value in my function, I'm going to multiply the parent y by A. Right? Just like with all the other transformations. K is also vertical, but it's vertical shift. And here I'm going to add K to the parent y values. Right? So anything on the outside affects the parent y's. On the inside, here I've got B and I've got H. Now remember, B is a little bit weird. That's horizontal stretch or compression. But if you remember, there's something weird about b, right? I'm not going to multiply the parent x value by b. Instead, I'm going to multiply the parent x value by the reciprocal of b. Right, so I'm going to flip b over. Right, and h is our horizontal shift. And what I'm going to do is I'm going to add h to the parent x values. Now, if you're looking at the filled in notes, I already wrote all that. Okay, guys, there's two extra things that we have to know about when it comes to trig functions in particular, right? And that is the amplitude. So the amplitude is how high are the mountains and how low are the valleys, right? The amplitude goes from, we call that the midline right here. That's the amplitude. All the way up, sorry. Right, that's the amplitude. And that's the amplitude. Right? So a good way of thinking of that is, we know the vertical stretch and compression is that A value. The amplitude is equal to the absolute value of A. Right? How high up and how low down does the graph go? The period, as I told you before, is one cycle of the graph. And the way we can do that algebraically is period equals 2 pi over b. So b is right here, right? We're going to do 2 pi over b, and that's going to be our period. Okay, guys, are you ready to graph our first transformation of sine? We are going to move the camera, it might be a little jiggly for a moment, over to this board. Okay. Okay, guys, let's see all this abstract stuff in action. What if I want to graph y equals 4 times sine 2 theta plus 3? Okay, that's super intimidating. Until I remember I've got my parent function over there, right? And our parent function is sine theta, right? So anything that's not sine theta is a transformation. So this is an A, this is a K, and this is a B. Right, so what I'm going to do, I'm going to draw the parent right next to it, right here. This is my parent function, y equals sine theta. You don't need to draw it, but I can't move back and forth really easily. So I'm just going to copy this down. Sorry. Okay, so there's our parent function. So what will we be doing? What's our little formula going to be when we're making our transform functions? Well, it says if I have an A and K, I'm going to multiply the y parent values by A and then add K. So my little formula for the y's is going to be 4y plus 3. Right? So that means I'm going to take all these parent values, 4 times 0 plus 3, 4 times 1 plus 3, 4 times 0 plus 3, 4 times negative 1 plus 3, and 4 times 0 plus 3. Right? So that's going to give me 4 times 0, 0 plus 3. 4 times 1 plus 3 is 7. 3, negative 1, and 3. Okay, and then what about our b value? Well, our b is 2. So if you guys remember, I'm going to multiply all the x parents, in this case they're thetas, by the reciprocal of b. So that means I'm going to multiply everything times 1/2. So 1/2 times pi over 2, 1/2 times pi, 1/2 times 3 pi over 2, 1/2 times 2 pi. Sorry, I just took all my parent values. So 1/2 times 0 is 0. 1/2 times pi over 2, I'm just going to multiply straight across. So 1 times pi and 2 times 2. 1/2 times pi is pi over 2. Again, multiply straight across. 1 times 3 pi, 2 times 2. And then 1/2 of 2 pi is pi. Okay, guys, let's graph this. Oops, I didn't write the coordinates up here. 1, 2, 3, 4, 5, 6, 7. Okay, so let's graph. We're going to graph our transform table here. So 0, 3, pi over 4, 7, pi over 2, 3, 3 pi over 4, -1, and pi, 3. Okay, this is one period of our graph. Now, if we want, we could just keep on doing the fun here and graph a few more of them. Oop. Wait, no, I didn't do that. Here I said it. Okay, so that goes up here, sorry. There we go. Okay, so that's if we want to do a few more. Okay, so what they want me to do is they want me to identify the amplitude, right? The amplitude is equal to the absolute value of A. Well, what's A, guys? Right there. It's equal to the absolute value of 4, which is 4. And I can see that, right, guys? I can see there's my midline, and this is up 4. So that's my amplitude. My period is equal to 2 pi over B. Well, what's B, guys? B is 2. So it's 2 pi, right? B is 2. I can see it in the equation. 2 pi over 2, which is pi. Right? So that's my first example. Okay. Normally I would say, are there any questions, but nobody's here. Okay, let's try this one, slightly spiced up because it has an H value. Okay, guys, let's identify what we've got here. It looks like we've got an A. Do we have a K? How can I tell whether that's a B or a K? Well, if it's in, H or a K. It's in the parentheses with the theta, that's an H. And that's a B. Right, so again, let's look at our parent function. I'll just draw it again down here. Should have thought through this. Okay, so for our y values, right, we only have an A, we don't have a K. So our formula is going to be 4y. So I'm going to take all these parents and I'm going to multiply them times 4. Right? So that's going to give me 0, 4, 0, -4, and 0. Okay, here's the part that's going to be challenging. I have a B and an H. So what's my formula for theta going to be? Well, I'm going to multiply by the reciprocal of B. And remember, even though that says x theta minus pi over 2, do you guys remember it's that kind of weird thing where you have to do the opposite, right? I'm actually going to add pi over 2. So this is going to be a little bit harder mathematically. So what's 2 times 0 plus pi over 2? Well, 2 times 0 is 0. So plus pi over 2 gives me pi over 2. How about 2 times pi over 2 plus pi over 2? Well, 2 times pi over 2, do you see how I can cancel those out? So that's just equal to 1 pi plus 1/2 pi. Or in other words, 1 1/2 pi, which we always write here as improper fraction, 3 pi over 2. Okay, 2 times pi Again, I'm just using the parent values. That's 2 1/2 pi, or 5 pi over 2. Okay? 2 times 3 pi over 2 plus pi over 2. Right? Again, those 2's go out, and I have 3 pi plus 1/2 pi. So that's 3 1/2 pi, which is 7 pi over 2. Can anyone see the pattern? 3 pi over 2, 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. What's the next one, guys? 9 pi over 2. Okay, so let's sketch this. So I'm going to sketch pi over 2 comma 0, 3 pi over 2 comma 4, oops, didn't do the y-axis here, 5 pi over 2 comma 0, 7 pi over 2 comma negative 4, and 9 pi over 2 comma 0. So notice this one looks much more stretched out, right? So if we want the amplitude, they asked us to find the amplitude and the period. The amplitude is equal to the absolute value of A, which is equal to the absolute value of 3, which is 3. Oh, oops. Miss Brinley, I did 4. Okay, guys, we got to change that to 4 because I screwed up. Someone would have caught it if I were there. We're going to change that to 4 because that's the one I did, not a 3. Okay, guys. If I want the period is equal to 2 pi over b. Well, what's b? B is 1/2. I can see that in the equation. So 2 pi over 1/2 is 4 pi. So there's my period, there's my amplitude. Sorry about that mistake. Okay, guys, so there are 2 graphing examples. Leave that for a sec, then I'm going to move it up. What if we have a description and we want to write an equation? Okay, so let's see what they give me here. They tell me that the parent is y equals sine theta. They say it's reflected across the x-axis. Does anyone remember what that means? That means that there's a negative sign out in front. It says that it's reflected across the x-axis. It doesn't look like it has any stretch or compression. They didn't tell us vertical stretch or compression. So I'm going to write sine, but they did tell us about a period of 6 pi. So we know that period is equal to 2 pi over b. So do you guys see how we can find the b value? Let's multiply both sides. First of all, we know the period's 6 pi. So let's multiply both sides by b. And I get b times 6 pi equals 2 pi. Right? Now let's divide by 6 pi. And I get b equals 1/3. So I know I'm going to have a b value of 1/3. Okay, then they also tell me that I moved left 3 pi over 4. So that means I'm going to have theta minus 3 pi over 4. Move left would be plus 3 pi over 4, and up 1 unit. And there is our equation. Right? They didn't tell me anything about vertical stretch or compression. They just said it was reflected across the x-axis. Okay, guys, grand finale. Got to scooch back over. What if we've got ourselves a graph and they want us to identify the amplitude and the period? Okay? Well, the amplitude we know is how high is the mountain or how low is the valley. So that's the amplitude right there. So the amplitude, if you look, is 4, right? Because it goes from 0 to 4. Okay, period. Oops, I did not draw this very well. I find find the easiest way to do the period is to go from mountain to mountain. This is the period right here. From the mountain to another mountain, or the valley to another valley. Here I have only one valley, so I'm going to go mountain to mountain. So I go from pi all the way until 5 pi. So the period goes from pi to 5 pi. So what is the period, guys? The period is 4 pi. Right? And the amplitude is 4. Okay. Now they want us to take this information and write ourselves an equation. They're assuming that there is no h or k. So that means we aren't having any shifts. So if I want to write, all I need here is a and b, right? Because there's no h and k. Well, the amplitude is equal to the absolute value of a, right? So I know that that's going to be my amplitude. The period is equal to 2 pi over b, right? So we said right here the period is 4 pi. So guys, we just need to find b, and then we're done. Let's multiply both sides by b. I get b times 4 pi equals 2 pi, and then I'm going to divide by 4 pi. So it looks like b equals 1/2. So I just need to write that. And no h and k like they told me, and I am done. All right, guys, see you next time for cosine.